I've never had a drum roll before. That's definitely a first. Is the microphone okay? I don't like being tied to the podium, so I'm more of a march around the room sort. So this presentation is going to be, it's a little rough. It's something I've been developing over the past year or so, and I've seen a few faces in the room that might have seen a version of this. And the motivation for this is that I get asked to talk about this a lot. I've done it a lot over the past 20 years, really. And you typically, the people who show up, and I suspect we're the same here, we're all convinced that the science tells us it's happening. We need to start doing something about it. But the impediment to actually doing something about it is there's still a large number of people who are unconvinced by the science. And this, in my view, this has become more and more a very polarizing sort of issue. You know, there are believers and non-believers. You know, for a scientist, belief, non-belief is a non-issue. Okay, so we don't go by belief. But what I've decided is that if we're really going to start having a conversation about what needs to be done instead of whether the science is believable or not, we need to convince the unconvinced. And one of the important first things you need to do, and so the point of this talk is, if I have an audience of unconvinced, and I've actually been searching them out. I have. I mean, I'm serious. Those are the people I need to be talking to. You folks are convinced. Is there anybody here who's not convinced? I would love to have you come sit right in front, because this is the people I'm trying to talk to. So why would I give this talk to folks like you? It's because you need to be talking not to each other. You need to be talking to your neighbor. You know, so the people who may not be convinced. And so this is maybe it's a little presumptuous, but I'm going to try to tell you, when these questions arise, what are the parts that you're not convinced about? What are the questions you have? This is to try to help you a response, you know, from that point of view. So I've been developing this. It's rough, still working on it. And for you, I actually, like I said, I found an audience of the unconvinced. It was kind of a bizarre thing. A person invited me to be the keynote lead-off speaker in a conference in Tallahassee and of like water managers. And he told me they're definitely unconvinced. They're very skeptical. They've avoided this issue entirely. He said, but this year I'm in charge of the program and I've snuck you in without telling them. So, when I started talking, I was talking to a room, it was about this kind of size. I was talking to the room, I started, and it was like, I got the coldest. But by the end, the people, at least 20 of these people caught me outside, and we talked for almost 2 hours, you know, and I think I convinced a few of them. So, but that's what we all need to be doing. And the point of this talk is trying to give you just my perspective on some of the questions that come up and how you might respond to them, okay? All right. So we're just going to go through some of the things that you're going to read. It's on the internet, so it must be true, right? So, but what I'm going to try to do here is when people make these objections, okay, I'm actually working with a science communicator sort of person too in trying to develop this. And I'm trying to turn this into a book chapter. And the first thing you have to do is you have to resist rolling your eyes. Going, jeez. Okay? That doesn't convince anybody. It just puts them off, you know, and it polarizes the situation worse. You have to accept this as a question, and you have to answer the question. So one of the first ones I hear about, and I've tried to track down as near as I can the source of the objections, because most of these things, there is some truth underneath it that has somehow gotten out of control. So the greenhouse theory, CO2, greenhouse effect, you've all heard of that. It's unproven. And there's a reasonable question here. I weigh myself every morning. It's a habit. I get out of bed, step on the scale. My wife says, why do you like to start every day with a dose of depression? So But it's a habit. And you know what? If you all, those of you who do something like this, do you weigh the same thing every day? Even if you're stable, or even if it's going up or it's going down, it fluctuates. Did you have a salty meal last night? Water, are you dehydrated because you drank beer with Jennifer last night? Whatever. So those fluctuations are perfectly natural. How does a bathroom scale work? It doesn't matter what type of scale it is, at the end of the day, it comes down to Newton's law of gravitation. Okay, you measure your gravitational attraction, depends on your mass, therefore your weight. So with those fluctuations day to day, and something else, suppose it's not my scale, suppose I go to my neighbor's house and use their scale after getting dressed. So I get a different answer there. Slight fluctuations. Does this disprove Newton's law? No, it's the calibration of the scale and its normal noise and fluctuation, natural variability. This greenhouse theory is unproven. I've tracked down, I believe it basically comes down to people saying the different climate models. There's a parameter called the climate sensitivity that says if you increase CO2 by this much, you get this much temperature change. In some models, that's an explicit parameter. In others, it's what we call an emergent parameter. And there is some variability. So they point to that variability, just like my variability in my scale. And they say the theory is unproven. That statement is just like saying that if my scale and your scale give a different answer, Newton's theory is wrong. Okay, so it doesn't work that way. So the greenhouse theory is right, and this climate sensitivity says for a doubling of CO2, you might get 1 degree, 2 degrees, or 4 degrees. There is not a single model out there that says if you double CO2, you will not get warming. Okay, so even the range there is all still consistent with the greenhouse theory. So greenhouse theory, though, it's brand new stuff. It's too new to trust. Just some numbers, write these down. This is interesting. The first paper on the greenhouse theory, for those of you who did statistics in college, the Fourier transform, the Fourier series, Joseph Fourier wrote the first paper on the greenhouse effect in 1827. Okay. Arrhenius, in 1896, already computed, based on the CO2 concentration of the atmosphere, the mean temperature of the Earth. Okay, so we knew how the greenhouse effect worked to the level of being able to compute the mean temperature of the Earth before 1900. Okay, so this is 19th century physics, very well established, so certainly not new. CO2 changes are natural. There is natural variability. This is true. And I gave some of this just for your entertainment. I gave an interview on Channel 10 in St. Petersburg a while back about sea level rise in Tampa Bay. And the next morning, one of the drive time talk radio, the local host who precedes Rush Limbaugh, just went off on me. I was ignorant. What kind of scientist? A fake scientist, a liar. And the thing underneath it all was, I was ignorant of, have you never heard of ice ages? Don't you know, I'd never heard of ice ages was on the radio. And the kernel here of what's true is there is natural variability. So try to put it in perspective for folks. I'm showing you the plot, but you can just remember the numbers. Because remember, when you're talking to people, the plots don't help. You need to just talk to people. And the numbers are here, well, you can see it, CO2 and years before present. These are the Ice Age interglacial warm phase cycles, okay, going back about half million years. So the low CO2 is the Ice Ages, 200 parts per million. You only remember 3 numbers is all you need, 200 parts per million. As we go from an Ice Age to an interglacial warm phase, this is the largest climate fluctuation known on the planet. We go from 200 to 300, an increase of 100 parts per million, not even a doubling, 100 parts per million. In the last 100 years, we've increased it from 300 to now over 400. So human activities have increased the CO2 in 100 years by larger than results in an ice age to a warm phase. Okay, so that is the order of magnitude here. We're telling you that you should expect a number of feet of sea level rise and a few degrees of temperature change. Ice age to interglacial, that 100 part per million change, sea level increased by 400 feet, and the temperature increased by 15 degrees Fahrenheit, roughly. So the numbers we're giving are actually quite modest. Okay? And we're going to wait and see what the models say. So to put it in perspective, there is natural variability, absolutely. But it has nothing, we have never done anything, we've never seen anything like this in the past. And those changes in the past, those natural variabilities, resulted in changes on the planet that are much larger than we're even predicting. Okay, so to put it in perspective. So anyway, I'll leave. I'm not going to name the person. So, okay, it doesn't matter. None of this stuff really matters because the temperature changes we see don't agree with the theory. I will hear this. And this is just, I've just picked a temperature curve, okay? And what they're saying here is interesting, is that they say, well, CO2 is increasing. The models say temperature should be increasing. They're implying smoothly and regularly. Like your bathroom scale has to say the same thing every day. You remember I was talking about we expect natural variability, and you need to be looking at the trend, the overall, the large scale sort of tendency. Okay? So when you look at this, people will go, well, if you're trying to be skeptical, you're going, well, if CO2 is increasing the temperature, why come from the 40s to the 1980s or so, was it decreasing a little? Natural variability. Use the bathroom scale analogy. And then you say, well, look, let's look at this another way. Let's just take these labels off, change it to stock market index. Are you going to invest in this market?
Yes.
Right. I'm selling my house, putting all the money in the market. And this is another thing that actually works quite well with people. It's an analogy that most people can warm up to and say, well, you know, you're right. There's always fluctuations in the market. They accept that. And they look at the trend to decide whether or not to invest. So common sense will tell most people. As a scientist, I don't believe in common sense. Okay, I have to use statistics. But for most people, they will say, you know, you're right, temperature's increasing. Okay? So the use of the stock market analogy. Yeah. You know, and a lot of people are very skeptical about this 98% of climate scientists consensus. And at that group in Tallahassee, one of the people who followed me out, who talked to me for quite a while, and he was very serious, sharp guy. He was an environmental lawyer, okay, an attorney. And he said, you know what? He said, you know, it doesn't matter what the topic is. There's always experts on both sides, and we each call them, and they, you know, put different points of views out there. And so I stopped. I said, but wait a minute. I said, I've actually never had to talk to an attorney before. I've been fortunate. And I said, but I've seen them on Law and Order. And he's like going, oh, great. So I said, no, when they have expert witnesses, don't you guys interrogate them on their credentials? He says, well, yeah. I said, here, when you're reading something on the internet, are you looking at the credentials? If you do that, you'll find out very quickly that a lot of the climate experts that you hear talking, there's no training in climate. Self-professed experts. One of the best known, closest thing to climate science was he worked on widgets for the NASA space shuttle. He's an engineer, but somehow has now become a world-renowned climate scientist. In my area in sea level rise, one of the experts that gets pointed to quite a bit, we hadn't heard of him for 10 years. He'd retired. And then came back and was giving talks all over the world about it was all a hoax and craziness and this and the other. All of his funding was not to do science or write papers. It was to travel around the world giving this talk, funded by the North Sea oil and gas industry. Okay? So look at the credentials. That's all you need to say. Look at the credentials for your experts. So Okay, so temperature increases a little bit. Who cares? Well, this is the data for sea level rise. The black curve here is the satellite measurement of the sea level change. And you say, well, okay, I can see it's increasing. I'll give you that. And I said, but do you really trust those satellite data? I said, you know, we do, because we're very fortunate now in our observing system that we can also measure for the global sea level. What we're really measuring is the volume of the ocean. Okay? This is a bathtub. The bathtub model gets poo-pooed, but that's for regional sea level changes. For the global mean sea level, the average is just measuring the volume of the ocean. The volume can only change two ways. You can either add water or subtract water, okay? Or you can warm it up or cool it down, because warm water is less dense, takes up more space. Okay? We can measure both of those things now from space. We measure the Earth's gravity, and we can weigh the ice sheets. And we can weigh the ice sheets, and if the ice is decreasing, the water is flowing into the ocean. So we can measure what we call the mass contribution. We have an Argo float system now, a system of 3,000 floats globally, that we can measure the density of the ocean due to the warming. We measure those completely independently. We add them up, get the purple curve, and it agrees with our completely independent direct measurement. This is what we really like. Scientists really like being able to get the same result from two completely independent lines. It's a robust result. So we have complete confidence in this satellite sea level curve. So now here's what gets interesting, and this is where it gets sticky, and this is where the last paper that I was part of comes into the picture. People say, okay, well, you look at that curve I just showed you. It's going up at 3 millimeters per year. That's only about a foot by 2100 or so. But you guys are telling us 3, 4, 6 feet. Where's all that extra coming from? Because it's not just increasing, we're saying it's not just increasing, it's going to be accelerating, going up faster and faster and faster. Okay? So where do we get that from? It's not in the data. Well, we get it from our climate models. They say, yeah, that's the part I don't like. You're using these fancy computer models, and I don't trust the models. I want to see it in the data. You know what? That was the basis for the North Carolina law that everybody had so much fun with about they've outlawed sea level rise. They said that you cannot project and put restrictions on developers until you see it in the data. Okay? And as a scientist, you know, I don't like computer models either. You know, I mean, I trust them more than most people because I know the math, but it's a valid question. You know, and the reason we can't see it yet is because the acceleration is still relatively small, and the data has noise in it, just like my bathroom scale. Going back to the bathroom scale again, but now, sorry, the paper that I just referred to, Steve Niram was the lead in Colorado. We've been working on this for 20 years now. And 10 years ago, we put out a paper saying, when are we going to be able to detect it? And we said 5 years ago, and we couldn't. But we published this paper earlier this year that the bottom line of this, it's a very technical paper. My part of it was the statistical analysis. And what we're saying now is, from the data alone, directly from the satellite data, we have detected with 99% confidence the predicted acceleration in sea level rise, predicted by the models. And not only have we detected non-zero acceleration, the magnitude of it agrees with the last IPCC projection, if you're familiar with IPCC, and the model projection for the model scenario that says business as usual, no action taken, which I think is a fair assessment of the past 10 years. Okay? So now, I think that objection, we don't need to take action because we don't believe the models and we haven't seen it in the data, that's not true anymore. I think that's the real impact of this paper. You know, obviously I'm biased. But the real impact of this paper is that when people say, oh, it's just models, show me the data. We've shown you the data now. Okay, and so we can honestly tell people we do see it in the data. Okay.
Is the full text of that article available? Is the full
Yes,
text?
yes. And if somebody will remind me, I'll email a PDF of it. But it's in, okay, so what happened here? Okay, now, that's 100 years from now. You know, I'm almost 62, what do I care? Okay, so when somebody, I do get that, by the way. And, you know, somebody talking to somebody and, the easy response is, well, I have kids, and I have a nice house on the water with only 7 feet of freeboard. I'm going to live there happily the rest of my life. I'm not going to give it to my kids. Okay? I don't consider it an investment property. So, but it's not just sea level rise. We're already seeing effects. And the two things that in St. Petersburg we talk about a lot, and you hear about it in Miami, where I grew up, in Charleston, South Carolina, Norfolk. All of these places we talk about what we call nuisance flooding or sunny day flooding, these kind of things. And the thing that we're finding out now is that this is not just, this is telling people, well, why should I care? We have this little tiny bit of slow rising sea level. We have more than that going on. It's not just that background sea level rise. What we're seeing is that the frequency of these flooding events, there's small flooding, nuisance flooding, but if you ask the city public works people, there's a huge cost involved. There's a big cost involved. And since 1960-ish, this is some work of Billy Sweet and NOAA, who's we're on a proposal together to study this right now in St. Petersburg. And there's been a 300% increase in the number of those events. More than we can account for by just the sea level background went up a little bit. Something else is going on. And that's what our present research is trying to sort out and trying to predict and project. In addition, rainfall. Severe rain events are what nail us in St. Petersburg because the water can't run off fast enough. Okay? And to be honest, if you're getting flooded, it doesn't matter if the water is coming up from the ocean or down from the sky. Okay? It's a flood. Okay? And so what we're seeing now is that we're seeing changes in the rainfall patterns where even if you get the same amount of rain over the year, we're getting it in shorter duration, heavier intensity burst, okay, which our runoff systems are not made to deal with. Okay? So we're getting flooding due to heavier, more intense rain events. And there's a good physical reason for that. If you can think about, if somebody asks about this, well, why is that? The main thing is that we have another 19th century physics, and you don't need to remember the name, it's Clausius-Clapeyron, which says that the amount of water that air can hold goes up exponentially with its temperature. So if you increase the temperature of the air by a degree, you increase the amount of water it can hold by 7%. So warmer air, you have the thunderstorm, normal afternoon thunderstorm, but if the air is holding more water, you get a more intense thunderstorm. We're so used to talking about relative humidity, it's 100% of what it can hold. We forget about the fact that how much it can hold, the absolute, depends on temperature. And the temperature is increasing. So these kind of events are going up. We're very concerned about what's going to happen with hurricanes. Okay? So are we going to have fewer, more? The climate projections are we're going to have fewer but more intense hurricanes. The thing I'm more worried about is where we live, is pretty much a void. We're not on the hurricane tracks, really. They tend to go up the East Coast or up to the northern Gulf Coast. Climate changes, the large-scale atmospheric patterns will change, the tropics will expand, and we could end up on a track. That's something else we need to tell people. We need to worry about this and try to look for the best projections we have in order to plan for it. We need to have the discussion about what do we need to be planning for. I'm going to end this up then with, it's not just atmosphere, it's not just rain, it's not just sea level rise, and all these physical parameters like I deal with. I'm an ocean physicist. So there are also things like as the tropics expand, we're going to start seeing things like dengue fever and malaria in Florida, tropical diseases. We're talking about invasive species. And this picture was taken off my seawall. And this big old lizard, so ends up parked out off my seawall. So I called Fish and Wildlife, and I said, you know, there's this big old iguana in my yard, and I guess it's somebody's pet. And they said, no, actually, we have a wild colony is established just south of the Skyway, north of here. So the iguana are expanding their range. So we might not believe that things are warmer, but they're perfectly happy with it. So then I continued on to ask the guy, I said, well, listen, tame, pet or wild or whatever, can you come get it? It's an invasive species, right? He said, oh, we'd love to, we just don't have the resources. He said, but it's okay if you want to kill it. And I'm going, but you know what? I'm having this picture of my son with his cell phone and this YouTube video of this 60-year-old fat guy chasing a huge lizard around with a machete. Nah, not going there. So at any rate, that's the 20-minute version. I think I was pretty close, and so I'll be happy to have comments or questions or whatever. Thank you. Yes, ma'am.
Hurricane Harvey, Houston, the flood, the rain was the determining factor in the volume of the devastation economically in terms of 144,000 families out of their homes, billions. What comments do you have about an infrastructure of a major metropolitan area that was slammed not by the wind and not by the rain, but by the water?
We do have a climate, the climate models predict that more intense hurricanes, but fewer but more intense, which is what we saw this past year. And you know, Harvey and Irma, Maria, these were all similar sorts of events. I get a little nervous, to be honest, about trying to argue that every time we have an intense hurricane that it's climate change. You know, the statistics of that are a little more difficult. And I also like when I'm talking to people who aren't quite so convinced, I have to be careful not to kind of oversell as well. You know, that, but that sort of event, the more intense hurricanes, it is forecast as part of climate change. Whether or not, I just don't think that you should point to any particular event and say it's climate change. So the climate change, these are part of our normal weather. We've had intense hurricanes for a long time. At what point do we start seeing the statistics changing, modulating? That's a hard question.
More was the fact of the flooding as opposed to the wind, and they weren't ready to have the whole infrastructure be flooded out.
Yeah. So definitely a very heavy rain event. We had the similar event that we had with the sewage outfalls in St. Petersburg was a very similar thing. We had a storm go by that was not really much of a storm, but it was just a huge rain producer. And it completely overwhelmed the sewage, the groundwater, not stormwater, system. And that stormwater got into the sewage system and then just overflowed it. The amount of water that was coming to the sewage plant was 10 times what it should have been on that day if it hadn't been raining. So that's not sewage going out there, that's stormwater going through your sewage system. But again, it just overwhelmed the infrastructure. And that's the sort of thing that sunny day nuisance flooding has the same potential. So when the water has to go somewhere. Thank you. Okay. Sorry, she says 1 minute. We also have a thing that says 1 minute. So,
Pick one that you want to use.
Pick one. Oh. These are all good ones. You know, the third one down here on the left. How do you have civil conversations with people who aren't civil, basically? Okay? You know, I think, honestly, what I try to do is, and when my science communicator that I'm talking with about how do you have communications about things is, you know, the first thing you have to do is you just have to stay calm. and say, just let it go. But you have to ask them, you have to say something. When you say something like, I hear what you're saying. I hear what you're saying. I don't see it the same way, but let's talk about it. I found that works pretty well. People do listen. One of my favorite stories about conversations with not necessarily hostile, but non-believers is the last IPCC, a colleague asked if it was okay to nominate me for the IPCC assessment. And I thought about it for a while, and I'd just taken on the associate dean job, and I said, I would love to, but I just don't feel like I can right now. But then I couldn't resist. My father is in poor health, so he spends all of his day watching the Fox News channel. And so I couldn't resist. I pick up the phone. I said, Dad, how's it going? Yeah, good. I've been asked to be on this IPCC assessment. He goes, there's a little pause on the phone. He's almost 80 years old at this point. And he goes, do you have to use your real name? So you smile, and you just keep talking. But the main thing is when you're talking with someone like that, everything I've heard and my whole experience is stay calm, don't roll your eyes. Okay, that just escalates. Stay calm and acknowledge what they're saying. I heard they say something that you might have seen in my talk, hopefully. They say, I hear what you're saying. I wondered about that too. I saw this talk recently. That's all you can do. And I found that, to be honest, that with most people it works pretty well. The fraction of people that are absolutely honest to goodness, no way in hell, I don't want anything to do with this, they're out there, complete denial, skepticism, denial, is a pretty small fraction. There's probably nothing you can do about that 5–10%. Okay, but there are a lot of people out there who just have honest questions. And those are the people that I'm trying to talk to now. I don't need to talk to you folks. I'm sorry, it's up to you guys. Sorry.